I'm Anil Kumar sharing with you a test paper on sequences MCR3U. Now this is 2018 test paper, right? So it is 2018. We do have a question related to the year also. There are 6 questions in this particular test paper. I'd like you to pause the video, copy these questions, solve, and then look into my suggestions. And that should give you a good review for preparing yourself on this topic. So question number 1 here is, determine if each sequence is arithmetic, geometric, or neither. 3 sequences are given to you. Arithmetic sequences are those where a constant term is added. Geometric sequence, they are multiplied by a constant, right? Question number 2. State general term for the following sequence in simplified form. So these are the 2 sequences, 12, 6, 3, 1. Right, it's very clear what the sequence is. And then minus 10, minus 5, 0, and so on. Question number 3. Determine the number of terms in the sequence minus 45, minus 32, minus 19, minus 6, and so on till 124. Now normally in test paper you have simple questions like this, kind of startup or warming up, right? Now let's get into some good word problems. Question number 4. The 9th term in geometric sequence is 4, 5, 9, 2, 7 and the 3rd term is 63. Find the equation for the general term and list first 4 terms in the sequence. Question number 5. Find the value of x if k minus 1, 2 minus 2k, and k square minus 1 are consecutive terms of a geometric sequence. Question number 6, the last question in this series, is in 1705, English astronomer Edmund Halley noticed a pattern in recorded sightings of a major comet that was seen in 1531, 1608, and 1685. He analyzed records dating back to its first sighting in 239 BC and named it Halley's Comet. If every sighting has been recorded since 239 BC, how many sightings of Halley's have been recorded to date, which is 2018, okay? Was Halley's Comet seen in 1984? Justify your answer. So that is the quiz on sequences. I hope you find it interesting and useful. And you must have copied all the questions by now. If not, you can go back, copy these questions, and let's look into their solutions one by one. And let me also take an opportunity to review few concepts on sequences. I'll also provide you with links to help you solve similar questions. The first question here is, determine if each sequence is arithmetic, geometric, or neither. So here if you see, numerator is constant, denominator is changing by 1, decreasing by 1. However, the term is not changing by a fixed number, or nor it is getting multiplied, right? So this one is neither. Now here what is happening? So if you go from minus 8 to minus 5, we are basically adding 3, and then we are again adding 3. So that means it is arithmetic series, right? So this one is arithmetic series. Now in this case, the terms are 0.0005 and something like this. So when you're going from one number to the other, we are multiplying by a factor of 10. Each time we are multiplying by a factor of 10, and therefore this one is a geometric series, correct? So I hope that's straightforward. Question number 2 here is, state the general term for the following sequence in simplified form. So first let's figure out what kind of sequence this is. So we are given 12, 6, 3, 1.5 and 0.74 and so on. Now what do you notice here? We notice that as we move on, we are multiplying each term by 6 is half of 12, right? And 3 is half of 6, right? So it is times half. So basically, what you get here is a geometric sequence. Is it okay? In which the first term is 12 and the ratio is half. In a geometric sequence, nth term, the general term, is a times r to the power of n minus 1, right? So using this, you get your result, which is 12 times half to the power of n minus 1. Is that clear? So we get the solution for the first one, and that is how you can do it. The second one here is, first step, identify the type of sequence it is. So when you move from 10 to minus 5, let me rewrite. We have minus 10, minus 5, 0, and so on. So when you move on from the first minus 10 to minus 5 and then to 0, what do you see? We notice that we are adding 5 each time, right? So we are adding 5 each time. The first term a is minus 10. The common difference d is plus 5, and therefore the general term Tn can be written as a plus n minus 1 times d. So that is minus 10 plus n minus 1 times 5, and that is minus 10 plus 5n minus 5, right? And that gives you the result as 5n minus 15. So Tn equals to 5n minus 15 is your general term. And the previous one, we got Tn as equal to 12 times half of n minus 1, right? So I hope that is absolutely clear, right? Let's see question number 3 now. I'd like you to copy, pause, answer, and then look into my solution. Question number 3 here is, determine the number of terms in the sequence minus 45, minus 32, minus 19, minus 6, up to 124. So we have minus 45, minus 32, minus 19, minus 6, so on till 124. Right? What kind of sequence is this? So as you move on, what is happening? So as you can see, the common difference seems to be constant, right? So if you do minus 6 minus of minus 19, what do you get? It is minus 6 plus 19, or it is the number 13, right? So the common difference is 13 in this case. Let us check here. So in this case, it is minus 19, minus of minus becomes plus 32, which is again 13. And here also we have minus 32 plus 45. That is the difference of these two is 13. So what we see here is that the common difference is constant, and therefore it is arithmetic sequence, right, where difference is equals to 13. So we know that a is the first term, which is minus 45. D, the common difference is 13 for us, correct? So the general term, using the formula, we can write Tn equals to a plus n minus 1 times d. So that is the formula for general term, just as we had applied in the previous example. So we'll now apply the same formula and find the number of terms, right? Now in this case, we are given the last term, right, which is 124, but we have to find n. So we know Tn is 124. We know a and d, and we have to find what n is. So let us write all these numbers, rearrange, and find the answer. So we get 124 equals to a is minus 45 plus n we don't know, d is 13, right? So it gives us 124 plus 45 equals to n minus 1 times 13. So if you add this, you get 9, 6, and 1. We'll divide by 13, and that is n minus 1. 13 times 13 is 169, right? So we get 13 here, and if I add 1 to it, I get n, which is equals to 14. So there are 14 terms in this. So the answer here is n, or number of terms, is 14. Is that clear? So that is how you can solve this particular question. So let's move on and look into the next question. Question number 4. The ninth term in a geometric sequence is 4, 5, 9, 2, 7, and the third term is 63. Find the equation of general term and list first 4 terms in the sequence. So we are given it is the geometric sequence, right? So in geometric sequence, what are the formulas? Especially for the nth term. So Tn equals to a times r to the power of n minus 1, correct? We are given the ninth term in geometric sequence is 4, 5, 9, 2, 7. So we given Tn, where n equals to 9, and we are also given Tn where n equals to 3, right? So if I use this formula, we can actually let's do it. So, and what do we need to? We have to find the general equation and list first 4 terms. This is what we have to find. Okay, so if n is 9, so let's write down if n equals to 9. In that case, T9 equals to ninth term is 4, 5, 9, 2, 7, and it can be written as, we don't know what A is and we don't know what R is. R to the power of 9 minus 1, which is 8, right? So we get one equation which is let's say equal to, we get 4, 5, 9, 2, 7 equals to a times r to the power of 8. Now we know the third term, which is 63, equals to 3 times r to the power of 3 minus 1, which gives you 63 equals to a times r square. So we have 2 equations, as you can see here, right? 1 and 2. Now if I divide one equation by the other, that is to say, if I do equation 1 divided by equation 2, what do I get? I get 4, 5, 9, 2, 7 divided by 63 equals to r to the power of 8 divided by r square. Is that clear? Right? So that is what we get. Now we can take the calculator, divide the number on the left side. 4, 5, 9, 2, 7 divided by 63 is equal to 729, and r to the power of 8 divided by r square is 6, 8 minus 2. So basically r is equals to the 6th root of 729, right? So let's find the 6th root of 729. So we have 729 to the power of, let's say, answer 729 to the power of 1 over 6. 1 divided by 6, which is 3. So we get r as equals to 3, right? So we get r as equals to 3. Once we get the value of r, we can find the value of a also. So in this equation, we can say a is equals to 63 over r square, right? Now r equals to 3, so a is equals to 63 over 9, right? 3 square is 9, and 9 times 7 is 63. Perfect. So we know what a and r are. So we get find a is 7 and r is 3 for us. Now we need to write the general term and list first 4 terms. So the general term therefore can be written as 7, r is 3 to the power of n minus 1, right? So that becomes the first answer. that general term is 7 times 3 to the power of n minus 1. Perfect. To get all the terms, we know T1, right? T1 is A, which is 7. T2 is 7 times 3. 2 minus 1, right? 2 minus 1 is 1. That means 7 times 3 is 21. T2 is 21 times R, right? 21 times R, which is 3. So it is 21 times, we could say 3, and we get 63. And similarly, we can, I mean, this is the third term. And the fourth term will be 63 times 3, which is 3 times 3 is 9, 189. Is that okay? So these are the 4 terms. So the 4 terms for us are, 4 terms are A, which is 7, 21, 63, and 189. Perfect. So that is how you can answer it. So let's move on and do question number 5 now. Question number 5. Find the value of x if k minus 1, 2 minus 2k, and k square minus 1 are consecutive terms of a geometric sequence. Now we are given a geometric sequence where we are given 3 terms, which are k minus 1, 2 minus 2k, and k square minus 1. Now if they are in geometric sequence, right, I mean, they could be anywhere in the sequence, their ratio is constant, right? So what is important here is that we have a ratio is constant. It means that 2 minus 2k divided by k minus 1 should be equal to k square minus 1 divided by 2 minus 2k. Clear? That is what it means. Now, we can actually simplify these expressions and solve the value of k. 2 minus 2k could be written as, if I take minus 2 common, I get, if I'm taking minus 2 common, right? So I get k minus 1 in the numerator. And I get k minus 1 in the denominator also. Here, what do we have? K square minus 1. I could write this as k plus 1 times k minus 1. And as I said, we could take minus 2 common. I did it quickly. Let me take 2 common here this time. Both are same, but I'll show you a different way of doing it. If I take 2 common, I get 1 minus k. Does it make sense? Correct? Since I took minus common, I got k minus 1. Okay. So minus was helpful. We can cancel k minus 1, k minus 1. Here, if I cancel, this is k minus 1, this is 1 minus k. I get minus 1. Do you see that? I get minus 1. So basically what I have here is minus 2 equals to minus of k plus 1 over 2. Is that clear? Right? Now we have to solve for k. It's a simple linear equation. Easy to solve, right? So cross multiply. So we'll do cross multiply and solve. So minus minus becomes positive. I could write 4 equals to k plus 1, or 4 minus 1 equals to k. That's it. So we get our answer as k equals to 4 minus 1, which is 3, right? So which is 3 equals to k. Find the value of x if, okay, it is misprint. Find the value of k, it should have been, I'm sorry. Find the value of k, or it could be find the 3 terms. If the question is to find the 3 terms, since there is a confusion here, if k is 3, then first term is 3 minus 1. The second one is 2 minus 2 times 3. And the third term is 3 square minus 1. This is 3 minus 1 is 2. 2 minus 6 is minus 4. 3 square is 9. 9 minus 1 is 8. So the 3 terms are 2, minus 4, and 8. As you can clearly see, here r is constant, right? So r is equals to, in this case, minus 2. So it is indeed a geometric series. Perfect. So that is how you would actually solve it. So I hope it makes sense. Now let's look into the last question, which is question number 6. Question number 6. In 1705, English astronomer Edmund Halley noticed a pattern in recorded sightseeing of a major comet that was seen in 1531, 1608, and 1685. He analyzed records dating back to its first sighting in 239 BC and named it Halley's Comet. Part A is, if every sighting has been recorded since 239 BC, how many sightings of Halley's have been recorded to date? So we're talking about the year 2018, okay? Was Halley's Comet seen in 1984? Justify, that's part B. You can always pause the video, answer, and then look into my suggestions. So when were the sightings? Let's look into those times. So sightings were in the year 1531 and then 1608 and 1685. So do we see a pattern here? So if I check, then it seems that after every, what is the difference? Let's figure out what is the difference in these years when the sightings are being seen, right? So what we see here is, if I do 1608 take away 1531, what do I get? If I do 1685 take away 1608, what do I get? This was 1685. I'm sorry. 85, right? What do we? Let's do it. So we have 1608 take away 1531. We get number 77. And if we do 1685 take away 1608, we again get 77. So it suggests that there is kind of a series here, right? So that means we are looking for arithmetic sequence where common difference D is 77. Does make sense, right? Now another thing to note here is that the first sighting was in 239 BC. So that should give us A, right? So A is equal to minus 239. Since it is 239 BC, right? So minus will be the value for A. D, we just calculated as 77. So that should give you the general formula for the sightings, right? So the general formula will be equals to Tn equals to A plus n minus 1 times D. That is the formula. We'll substitute the values and then simplify it kind of. So the formula will be Tn is equals to A, which is minus 239, and then we have n minus 1 times 77, right? Sorry, I missed a plus here. Okay. To find the number of sightings, that is n, and we are taking Tn as the year, we are taking the nth year as 2018, right? So that's the year which we are talking about. So I'll replace this by 2018 and then find how many number of sightings were there. So let's substitute 2018 for Tn, 2018, and we have minus 239 plus, we'll find the number of sightings, n, minus 1 times 77. Let's rearrange. 2018 plus 239 and divide by 77 to get n plus n minus 1, right? So let's use calculator, figure this out. So we have 2018 plus 239 equals to, divide by 77 equals to, in decimals, 29.3, right? So we get approximately 29.3. That's what we get, equals to 9n minus 1. So the sightings have to be a round number, right? Sightings have to be round number. So we'll say n is equals to 29 plus 1, which is 30. So we have total 30 number of sightings to date in the given scenario, right? So the answer for the first part is 30 sightings. Now let's do the second part, which is, was Halley's Comet seen in 1984? Justify. So if it was seen, we should get a whole number and in this general formula, right? So let's substitute 1984 equals to minus 239 times, plus n minus 1 times 77, right? So let's rearrange this one. So we get 1984 plus 239, and then we'll divide by 77. That should be n minus 1, right? So let's calculate this value. 1984 plus 239 equals to, divided by 77 equals to, it's a fraction which is 28.87 n minus 1. Since we do not get whole number, right, we get 28.87 plus 1 as the n value. Since it is not a whole number, we say there was no sighting in the year 1984, just as there wasn't any sighting in 2018, right? So there must have been one before it sometime. So that is why we are 29.3, right? So not in 2018. That's what that decimal number signify. If you substitute values of one of these, right, or you can find when the next sighting could be, you'll get a whole number. So as an example, I will give you an extended question to this, which is question 6c. When will be the next sighting? Correct? So let that be a question for you to work out. So I hope that makes sense. It helps to do some previous test papers so that it prepares you for better achievement of marks and understanding of the topic. I feel you enjoyed this journey of learning. We'll share with you the test paper of sequences and series also. Feel free to write down your comments and suggestions. If you share my videos, like them and subscribe to them, that'll be good for me and you. Thank you and all the best.